So we just spent a lot of time talking about level curves for functions of two variables. Well, let's kick everything up a notch and start talking about functions of three variables. What's the corresponding thing here? Instead of having f of xy is equal to a constant, we're going to have f of xyz is equal to a constant. And so here is our definition here. We're going to call this a level surface. The set of all points in R3 in space where a function of three independent variables has a constant value, f of x, y, z is equal to c, is called a level surface of f. Okay, so let's just think about this. Describe level surfaces of f of x, y, z is equal to x squared plus y squared plus z squared. So that's going to be x squared plus y squared plus z squared is equal to a constant. And let's assume here c is, let's make this c be greater than or equal to 0. If c is negative, that won't work here. This is equation of a sphere centered at the origin of radius square root c. If c is equal to 0, it's just the origin itself. So what's going on here? If I draw some axes, if we have c is equal to 1, we have this sphere. If c is equal to 2, or 4, maybe I should go 4 to get the radius. Square root of 4 is 2. We have a bigger sphere, and then we do square c is 9. The next one would be there would be a third one here with radius 3. Square root of 9 is 3, and so if you just think about that, what's going to happen is that you're going to have lots and lots of nested spheres. And so what happens is that this suddenly becomes very, very difficult to draw. In contour maps and function of two variables, we really, we should be able to draw our contours without intersecting in the most cases. They won't be overlapping each other here. That's impossible. We're trying to draw these three-dimensional surfaces. Three-dimensional spheres on a piece of paper. Is going to get a little bit messy. And so we don't really draw level surfaces as much in, we don't make contour maps for level surfaces for function of three variables as much as we do for, functions of two variables for level curves here. It's okay to still draw one or two of them, but we don't draw all of them. And honestly, what really goes on is that you want to start using computers to do this. There's a section in the textbook you can read about computer graphing, and there will be exercises for you to play around with computer graphing. So that's what's going on here. Let me wrap up this little discussion by saying what goes wrong here is that we're trying to draw, and we have a function of two variables, and we want to draw draw pictures there. We need a third dimension. Now we already have three variables, x, y, and z. If we try to draw it, we end up hitting like 4 dimensions, and we can't draw this stuff quite as easily. So that's why we're not really drawing functions of three variables, except for in this level surface case. Okay. And then I should say here, definitions. There's definitions for interior boundary points of sets in three variables, sets in R3 in space. There's notions for open and closed sets in R3 in space. I'm not going to write out everything here. You can see the textbook for that. Everything goes through exactly in the same way as it does for functions of two variables and sets in the plane.